60 miles per hour is the velocity at which a massive locomotive displaces the air as it tears down the steel rails. It pulls hundreds of tons of freight with a mechanical ease that suggests the cargo weighs nothing at all. Why did the United States engineer such immense monsters on rails during the 20th century? A simple steam engine could move basic loads, but the geography of the continent demanded machines that could conquer steep mountain grades and cross endless deserts without faltering. These engineering marvels eventually became living legends of global rail transportation through their sheer scale and power. The process of discovering the 10 largest American locomotives ever built reveals a history of industrial extremes. Many of these mechanical giants remained unknown to the public for decades despite their significant impact on logistics. One can notice how the sheer mass of certain models was so great that the metal of the tracks actually sustained structural damage beneath the weight of the drive wheels. It gets more complex further on. Restoration efforts for these titans often required the technical expertise of former railroad workers who operated the machinery back in the 1950s. It seems simple to rebuild a retired engine, but in reality, the knowledge of those who actually ran them is necessary to bring the systems back to life. One can notice the way the camera glides along the massive boilers and the intricate linkage of the driving rods. The nomenclature of these locomotives often carries a sense of intimidation that commands respect the moment the name is spoken. Transition to the next level. Some of these machines were designed with such extreme specifications that they redefined what engineers thought was possible to achieve on steel rails. The final locomotive in this historical sequence stands as the most extreme example of American heavy industry, where the scale of the boiler and the diameter of the wheels exceed all previous standards of rail power. Thus begins a detailed journey across the most legendary rails in American history. 4,500 horsepower is the massive output generated by the Milwaukee Road 261. Why did the Chicago, Milwaukee, St. Paul, and Pacific Railroad commission such a powerful machine during the height of 1944? Engineering during the peak of World War II required a unique balance of extreme speed and mechanical reliability for passenger service across the American Midwest. The answer lies in the necessity to transport heavy consists across vast distances without losing time. This S3 class steam locomotive represents one of the final units ever produced for the legendary Milwaukee Road. The wheel arrangement follows a 4-8-4 configuration, a setup technically known as the northern type. It is visible how the 4 leading wheels guide the frame into curves, while 8 massive driving wheels provide the primary traction. 4 trailing wheels support the immense weight of the firebox at the rear. This specific geometry was ideal for maintaining high speeds while pulling between 15 and 20 passenger cars. It gets more complex further on. Pressure within the boiler reaches 250 pounds per square inch to facilitate this movement. One can notice the synchronized motion of the side rods as they translate steam pressure into kinetic energy. At this intensity, the locomotive could exceed speeds of 100 miles per hour on level track. But this is just the beginning. The combined weight of the locomotive and the tender surpasses 220 tons. Approximately 110 tons of this mass rest directly on the locomotive itself to ensure the driving wheels maintain a firm grip on the steel rails. A mechanical stoker delivers coal automatically to the firebox, a feature that significantly reduced the manual labor required by the locomotive crew during long shifts. The water capacity in the tender reaches nearly 24,000 gallons. The valve gear system utilizes the Walschaerts design, which remains one of the most respected and reliable mechanical configurations of the steam era. The process is only gaining momentum. At first glance, the 261 is merely a machine of transportation, but in reality, it is a masterwork of industrial aesthetics. The camera glides along the glossy black body and polished metal accents that define its external appearance. High-pressure steam vents with a sharp hiss while the deep, resonant whistle signals its approach. Preservation efforts are currently managed by the Friends of the 261 based in Minneapolis. The equipment gradually undergoes maintenance to participate in special excursions and public rail events. It only looks obvious that such a machine would be saved, but in reality, it nearly faced the scrapyard in the 1950s. A single railroad employee intervened at the last minute, recognizing the historical value of the structure when others viewed it as simple industrial debris. The transition to the next level of steam engineering reveals even larger dimensions. The locomotive continues to draw significant crowds, serving as a functional monument to mid-century American rail transport. From here, the narrative moves toward another machine that redefined the limits of visual impact and mechanical scale. 136 tons of streamlined steel and high-pressure passenger steam defined the Southern Pacific 4449. Completed in 1941 by the American Locomotive Company, this machine is widely regarded as one of the most beautiful steam locomotives ever constructed. Why did the Southern Pacific Railroad commission such an elaborate design for its West Coast operations? While standard locomotives of the era focused purely on utility, the 4449 was engineered to combine high-speed passenger service with an aesthetic elegance that became permanently etched into American rail history. This specific locomotive belongs to the GS4 class and utilizes a 484 wheel configuration. It seems simple to view it merely as a transport vehicle, but in reality, it served as the primary power for the famous Coast Daylight route between Los Angeles and San Francisco. 300 pounds per square inch of pressure builds within the massive boiler to generate an estimated 5,500 horsepower. This immense energy allows the locomotive to reach speeds exceeding 105 miles per hour, ranking it among the fastest steam engines ever built. An automatic stoker continuously feeds coal into the firebox to maintain this sustained high performance over long distances. One can notice how the 80-inch driving wheels are designed to maximize velocity while simultaneously minimizing mechanical wear during transit. But this is just the beginning of its technical complexity. The appearance of the 4449 remains instantly recognizable across the globe. Painted in vibrant shades of red, orange, and black with streamlined bodywork, the locomotive looks more like a high-velocity rocket than a traditional train. The camera glides along the polished exterior, where the tender, carrying more than 24,000 gallons of water, follows the engine. It is no surprise that the machine remains one of the most photographed objects in the world of rail transport. Its deep, melodic whistle creates an unmistakable sound that signals its approach from miles away. Everything only gets more complicated when considering its life after the era of steam ended. The equipment was carefully restored in the 1970s to lead the United States Bicentennial Train in 1976. Traveling from coast to coast, the engine served as a national symbol during the celebrations before eventually finding a permanent home in Portland, Oregon. An interesting detail often overlooked is that Clint Eastwood once operated the 4449 during a specialized filming session on a specific rail segment. Even Hollywood icons are drawn to the mechanical precision of this particular machine. The process of preservation ensures that the locomotive stays in peak condition for future generations. Transition to the next level of historical recovery. The next locomotive on the list was brought back from near extinction through one of the most ambitious restorations ever attempted. The material is ready to move to the next processing phase without haste. 400 tons of total weight represents the staggering mass of the Santa Fe 2926 when fully loaded with its tender. This machine functions as a vessel for both raw industrial power and a modern technical rebirth within a massive steel frame. Built in 1944 by the Baldwin Locomotive Works, the engine belongs to Class 2900 of the Atchison, Topeka, and Santa Fe Railway. One can notice how the reinforced frame supports the immense scale of this machine, which remains among the heaviest and most powerful passenger steam locomotives ever constructed in the United States. But this is just the beginning. Why did this specific design require such an extensively reinforced track infrastructure? The massive scale of the locomotive was a direct consequence of its specialized engineering requirements. The locomotive alone weighs over 226 tons, a physical presence that necessitated high-strength rail beds to avoid structural failure. The engine utilizes a 484 northern wheel configuration paired with a boiler pressurized to 300 pounds per square inch. This combination produces more than 5,000 horsepower, allowing for extraordinary pulling power during heavy operations. The process is only gaining momentum. High-speed service across the American Southwest defined the operational life of the 2926 as it cut through desert routes. It is visible how the 80-inch driving wheels allowed the locomotive to maintain sustained operation at speeds exceeding 100 miles per hour. Even when pulling long passenger consists, the mechanical systems remained responsive. Everything only gets more complicated as the steam flows through the internal mechanisms. Efficiency and control are managed by the Baker valve gear, which provides precise regulation of the steam throughout the stroke. At first glance, the external appearance is one of pure dominance, but in reality, every polished detail serves a mechanical function. The black body is accented by a tall headlight and exposed moving rods that create the visual impression of a massive beast in motion. One can notice how the rods oscillate with rhythmic precision as the locomotive gains speed. The sound of the steam exhaust and the deep rumble of the boiler are physical sensations that accompany the movement of the machinery. After being retired in 1956, the locomotive spent several decades as a static display in a park setting. It does not end at this stage. A dedicated volunteer group in New Mexico undertook a complex restoration process that lasted for more than 20 years of continuous labor. The equipment gradually returned to a functional state through thousands of hours of technical overhaul. Today, the 2926 is once again operational and stands as one of the largest working steam locomotives on the entire planet. During initial test runs, the engine passed through a residential neighborhood, creating a striking contrast between the mid-century industrial giant and modern suburban life. Documentation of this event captured the essence of a machine from the 1940s returning to active service. The transition to the next level of steam history follows this mechanical revival. Nickel Plate Road 765 represents the next stage of evolution in steam technology. This locomotive became a primary symbol of operational efficiency during the height of the steam era. The journey through the history of massive rail power continues with this legendary machine. From here, the narrative moves to the next phase of technical exploration. 284 is the specific wheel arrangement that defines the Berkshire type of the Nickel Plate Road 765. Why was this particular configuration of 2 leading wheels, 8 driving wheels, and 4 trailing wheels chosen for such a massive machine? Engineering requirements for the New York, Chicago, and St. Louis Railroad demanded a platform that could maintain high speeds while hauling heavy freight across varying terrain. This specific setup provided the necessary traction and stability required for navigating steep grades and sweeping curves without losing momentum. Lima Locomotive Works completed the construction of this S2 class giant in 1944. It was designed specifically for the demanding freight service of the era, where power and reliability were paramount. But this is just the beginning. The heart of the machine is a boiler that operates at 245 pounds per square inch. This internal pressure allows the locomotive to produce approximately 4,500 horsepower, an immense figure for any freight hauler of that historical period. One can notice the 69-inch driving wheels that strike a precise technical balance between raw pulling force and high-speed capability. These massive steel discs allow the locomotive to reach speeds of up to 80 miles per hour when the schedule requires rapid transit. It only looks obvious that such a machine requires vast amounts of fuel, but in reality, the logistics of its tender are equally impressive. The tender carries 24,000 gallons of water and 22 tons of coal to sustain the firebox. An automatic stoker delivers the fuel continuously, ensuring maximum thermal efficiency during long, uninterrupted runs across the rail network. The mechanical presence of the 765 is defined by a distinct auditory profile. Its sharp whistle pierces the air, while the deep roar of the boiler and the rhythmic impact of the heavy side rods create a complex industrial soundscape. Visually, the locomotive remains rugged and purposeful, characterized by a polished black finish that emphasizes its classic proportions. Everything only gets more complicated when considering its transition from active service to a historical icon. After being retired in 1958, the locomotive underwent a meticulous restoration process managed by the Fort Wayne Railroad Historical Society. Since its return to the rails, it has been utilized for public excursions and various special events. It has even appeared in film productions, frequently serving as a stand-in for other famous steam engines due to its prototypical appearance. The process of maintaining such a machine is only gaining momentum as it continues to operate decades after its peers were scrapped. One lesser-known moment in its history occurred in 1985 during a specialized excursion. The 765 was required to cross a steel bridge that was already more than 100 years old. It is visible how the massive structure shook under the weight of the moving steel, causing engineers to hold their breath in anticipation. The locomotive passed over the span flawlessly, earning a wave of applause from the spectators gathered along the riverbanks to witness the crossing. The next locomotive is a living relic and stands as the final steam engine built for a major American railroad that remains operational today. This is the Chesapeake and Ohio 614 Greenbrier. The transition to this next piece of history marks the end of the steam era's peak production. Thus, the legacy of the Berkshire type remains preserved through consistent mechanical care. 220 tons of steel and iron comprise the massive frame of the Chesapeake and Ohio 614, a locomotive famously designated as the Greenbrier. Why did the major railroads of the United States continue to order steam power as late as 1948? It only looks obvious that diesel would take over, but the Lima Locomotive Works engineered this machine to prove that steam could still dominate the most demanding mountainous corridors between West Virginia and Ohio. This specific model represents one of the final high-performance steam orders ever placed, specifically designed to haul heavy express passenger consists through steep grades and sharp curves. The process of generating 5,000 horsepower begins within a boiler operating at a pressure of 255 pounds per square inch. But this is just the beginning. This energy is transferred to a set of driving wheels measuring 74 inches in diameter, a dimension that perfectly balances raw pulling tractive effort with high-speed capability. One can notice how the rhythmic motion of the external running gear remains smooth even as the locomotive accelerates toward its maximum operational speed of 80 miles per hour. Everything only gets more complicated when considering the logistics of fueling such a giant over long distances. The massive tender attached to the rear of the engine carries 28 tons of coal and 25,000 gallons of water to sustained high-output operations. An automated stoker system feeds the furnace ceaselessly, ensuring that the firebox maintains a consistent temperature without the fluctuations of manual shoveling. It is visible how the refined valve controls and real-time pressure monitoring systems allowed the crew inside the cab to manage these forces with a level of precision that was considered advanced for the mid-20th century. At first glance, the aesthetic of the Greenbrier suggests mere elegance, but in reality, every visual element serves the functional identity of a mountain conqueror. The locomotive is finished in a deep, refined dark blue with gold accents, while a high-mounted headlight cuts through the mountain mist during night runs. The equipment gradually creates a hypnotic visual effect as the rods and pistons move in synchronized harmony, accompanied by the mechanical resonance of a whistle that echoes for several miles across the valley floor. The history of the 614 is divided into several distinct phases of service and preservation. After its initial retirement in 1956, the locomotive underwent a full restoration in the 1980s and later served as a mobile laboratory for clean coal efficiency testing during the 1990s. Today, the machine remains preserved under the stewardship of Ross Rowland, a figure central to the survival of American rail history. The process is only gaining momentum as the locomotive continues to serve as a physical record of the transition from the steam era to the modern age. 100 tons of trailing weight usually require multiple locomotives on steep grades, yet the 614 once achieved a feat that silenced its competitors. Without the assistance of any helper engines, it successfully hauled a 24-car passenger train through the rugged West Virginia mountains. This demonstration of solo power proved the inherent strength of the 484 wheel configuration under extreme stress. The locomotive moved the massive weight with calculated steady traction, reaching the summit through mechanical endurance alone. 4 locomotives remain in this technical survey, and the scale of the machinery is now transitioning to a truly colossal level. The next entry is the Union Pacific 844, a machine frequently referred to as a living legend. This locomotive represents the pinnacle of high-speed passenger steam design, maintaining a continuous operational status since its construction. From here, the narrative moves toward the largest articulated frames ever to move on American rails. 484 is the wheel configuration that defines the structural foundation of the Union Pacific 844. Why has this specific machine managed to remain in continuous operation for 8 decades while every other steam engine of its era faced the scrapyard? The answer lies in its unique status as the only steam locomotive from a major American railroad that has never been retired from active service. Built in 1944 by the American Locomotive Company, this giant of the FEF3 class has remained operational since the day it was delivered. It only looks obvious that a machine of this age would be a museum piece, but in reality it is a fully functioning high-speed powerhouse. One can notice how the 80-inch driving wheels carry a massive boiler designed to operate at 300 pounds per square inch. This internal pressure allows the engine to generate an impressive 4,850 horsepower. The machinery is capable of propelling the 220-ton locomotive to recorded top speeds exceeding 100 miles per hour. This velocity places it among the fastest steam-powered units ever to operate within the United States. But this is just the beginning. The locomotive is paired with a massive tender designed to carry 25,000 gallons of water and 24 tons of oil fuel. Initially designed for coal, the system underwent a technical conversion to oil to simplify modern maintenance procedures while preserving its original historic performance performance parameters. It is visible how the gleaming black finish and silver accents catch the light alongside the distinctive Union Pacific shield. The deep resonance of its whistle creates an auditory spectacle that draws crowds to the trackside whenever the engine appears on the rails. Everything only gets more complicated when considering the emotional history attached to this specific hull. In 1971, the 844 was tasked with pulling the funeral train of a former Union Pacific president. The very locomotive he had once approved for production carried him on his final journey. Employees gathered along the line to provide heartfelt applause as the steel giant passed by. Transition to the next level. The nickname Living Legend is a technically accurate description of its status in the modern era. Today, the machine continues to function in excursion service and commemorative events, serving as a physical symbol of industrial pride. It stands as a bridge between the era of steam and the modern rail network. The process of exploring these giants is only gaining momentum. As the scale and power of these machines reach another level entirely, the narrative moves toward the Union Pacific Challenger 3985. The transition to the final four locomotives marks a significant increase in mechanical complexity and sheer physical mass. 270 tons is the weight of the locomotive alone, standing as a testament to the industrial power of the Union Pacific 3985. Why was such a massive 4664 configuration necessary for the American rail network? At first glance, the articulated design seems intended only for sheer scale, but in reality, it was the only way to allow a machine measuring over 120 feet in length to navigate tight mountain curves. This mechanical flexibility enabled the two independent sets of 6 driving wheels to pivot, ensuring the engine could maintain stability while traversing the complex topography of the western United States. The American Locomotive Company delivered this machine in 1943 to solve a specific logistical challenge. It was engineered to conquer the steep, punishing grades of the Rocky Mountains while maintaining high speeds for heavy freight transport. The boiler functioned at a pressure of 280 pounds per square inch, generating a massive output of more than 6,100 horsepower. Because of this immense power, the locomotive could reach speeds of 70 miles per hour even when hauling enormous loads that would stall lesser engines. One can notice how the synchronized motion of the articulated running gear creates a rhythmic mechanical harmony as the steel rods drive the wheels forward. It is visible how the tender follows closely behind, adding another 150 tons to the total mass. This support unit carries 25,000 gallons of water and more than 7,000 gallons of oil fuel to feed the massive boiler. Everything only gets more complicated when considering its fuel history, as the 3985 was originally built to be coal-fired before technicians converted it to oil during its service life. The locomotive remained in regular service until 1962, later undergoing a full restoration in the 1980s. This revival was part of the Union Pacific Heritage Program, returning the enormous black body and its thunderous whistle to the tracks for public demonstrations. For several decades, this machine held the title of the largest operational steam locomotive in the world. But this is just the beginning of its legendary status, as it only relinquished that record when the Big Boy 4014 returned to active service. In 1992, the 3985 completed a tour of more than 2,500 miles between Wyoming and California. During this grueling journey, the locomotive pulled a 25-car train without a single mechanical failure or technical delay. Few modern locomotives could match the reliability or the sheer physical presence of this articulated giant during such a long-distance trek. One can notice how the steam exhausts from the cylinders in dense white clouds as the pistons work in perfect coordination. The equipment gradually transitions from a state of rest to full power, demonstrating the peak of steam-era engineering. The transformation of water and oil into 6,100 horsepower remains a marvel of thermodynamics and mechanical design. As the heavy steel frame vibrates with the intensity of the internal pressure, the locomotive proves that its design was optimized for the most demanding environments in North America. The process of moving thousands of tons of freight over mountain passes was perfected through this specific articulated architecture. Thus, the legacy of the Challenger class is preserved as a final milestone in the evolution of steam power. 5,100 horsepower is the measured output of the Norfolk & Western 611. Why is this specific machine considered the most efficient passenger steam locomotive ever built? One might assume that steam technology reached its limit before the mid-20th century, but in reality, this locomotive represents the absolute zenith of post-war American engineering and aerodynamic refinement, emerging from the Roanoke shops in Virginia during 1950. The 611 belongs to the renowned J class, featuring a 4/8 wheel arrangement. It operates at a sustained boiler pressure of 300 pounds per square inch. One can notice how the 70-inch driving wheels were engineered specifically for a combination of high speed and mechanical smoothness. This precise design allowed the machine to exceed 110 miles per hour during straight-line service operations. But this is just the beginning. Everything only gets more complicated when considering the sheer mass and consumption requirements of such a vessel. The locomotive itself weighs approximately 220 tons and relies on an automatic stoker to feed the furnace. Its massive tender carries 25,000 gallons of water alongside more than 25 tons of coal to maintain its immense thermal output. It is visible how the streamlined black body, accented with red and gold striping, creates a silhouette that appears futuristic even by contemporary standards. The equipment gradually moves with a centered headlight and a smooth outer casing that minimizes air resistance. It only looks obvious that a machine of this scale would be loud and cumbersome, but in reality, the balance between power and efficiency was so refined that the Norfolk & Western used it as a primary showcase for their technical capabilities. The process is only gaining momentum. Its deep, clean whistle serves as a signature acoustic marker that remains instantly recognizable across the landscape. Retirement first arrived in 1959, yet the narrative did not end there. Restoration efforts in the 1980s allowed the 611 to run excursion services until 1994. In 2015, the locomotive returned to active service once more under the dedicated stewardship of the Virginia Museum of Transportation. Transition to the next level. During documented speed tests in the 1950s, the engine pulled 15 cars over nearly 90 miles while maintaining speeds above 100 miles per hour. Remarkably, the 611 consumed less fuel during these high-speed runs than many of the diesel locomotives emerging during that same era. The camera glides along the polished steel surfaces where the fusion of speed and brutal force remains evident. This demonstrates that efficiency and raw power reached a state of equilibrium before the transition to modern traction. The metal remains a testament to a period where steam design achieved its highest functional form. The locomotive remains a functional artifact of industrial history, preserved for future technical observation. 270 tons is the total mass of the Western Maryland 1309, the largest simple articulated steam locomotive ever constructed for standard gauge service in the United States. Why was such an immense machine necessary for the rail lines of the mid-20th century? The answer lies in the unforgiving geography of the Appalachian transport routes. Heavy freight service in mountainous regions demanded a machine that prioritized sheer pulling power over rapid movement. Constructed in 1949 by the Baldwin Locomotive Works, this engine represented the final H6 class locomotive built for the Chesapeake and Ohio Railway. It features a massive 2662 mallet configuration, utilizing two articulated sets of 6 driving wheels. This mechanical arrangement is ideal for navigating tight curves and steep grades where rigid frames would fail. The boiler operates at a pressure of 210 pounds per square inch. This internal pressure allows the locomotive to produce approximately 5,500 horsepower. The equipment gradually generates a constant tractive effort rather than high speed, which is a necessity for hauling massive loads over long distances. One can notice how the 56-inch driving wheels are sized specifically to emphasize torque and grip. The tender coupled to the engine carries 21,000 gallons of water and more than 20 tons of coal to fuel the massive firebox. It seems simple to operate a steam engine, but in reality, the 1309 utilizes a complex compound design. This system allows high-pressure and low-pressure cylinders to work in synchronization. Such a configuration increases fuel efficiency and ensures a sustained power output during the climb. For years, the locomotive worked under punishing conditions across rugged terrain, proving its worth on the most difficult Appalachian routes. Visually, the 1309 is a colossus of industrial engineering. Its body appears split into two massive sections, revealing exposed running gear that moves with rhythmic precision. A deep roar seems to rise from the ground itself when the pistons engage. But this is just the beginning of its history. After spending several decades out of service, the locomotive underwent a complete restoration by the Western Maryland Scenic Railroad. The project returned the machine to operational status in 2021. Restoration costs exceeded $3 million and were funded largely through public donations from around the country. Today, the engine operates tourist excursions as one of the very few operational articulated steam locomotives remaining in the world. The process of maintaining such a giant is constant. Everything only gets more complicated when considering the scale of the machinery that followed this era. The 1309 remains a testament to the peak of steam technology. The molten heat of its firebox and the hiss of its valves continue to draw crowds. From here, the narrative shifts toward even more massive subjects that once dominated the American landscape. Thus ends the record of the 1309 as it continues its journey on the scenic rails. 414 is the most famous designation among the 25 mechanical giants constructed by the American Locomotive Company between 1941 and 1944. Why did the Union Pacific Railroad commission such colossal machines during this specific era? The expansion of industrial logistics demanded a solution for hauling freight trains weighing up to 8,800,000 pounds across unforgiving terrain. But this is just the beginning. The result was the Big Boy, a machine that remains the largest steam locomotive ever operated in the history of rail transport. It only looks obvious that a train of this scale would be rigid, but in reality, the 4884 wheel configuration provided necessary flexibility. The design utilizes two distinct sets of 8 articulated driving wheels, which are supported by 4 leading and 4 trailing wheels. This mechanical arrangement allowed the locomotive to navigate curved tracks despite a total length of nearly 132 feet. One can notice how the articulated frame pivots to distribute the massive physical stresses of the iron road. The process of motion is only gaining momentum as the internal systems engage. 300 pounds per square inch is the intense pressure maintained within the massive boiler. This thermal energy generates more than 6,200 horsepower, enabling the machine to reach speeds near 80 miles per hour. Such velocity is an astonishing technical feat when considering the total weight of the locomotive and tender exceeds 1,200,000 pounds. The equipment gradually translates steam pressure into raw tractive effort through 68-inch driving wheels. At first glance, these wheels seem oversized, but they provide the exact balance required for torque and stability on steep mountain grades. The tender functions as a mobile fuel station of immense proportions. It carries approximately 25,000 gallons of water and over 6,600 gallons of oil fuel following its technical conversion from coal. These reserves were essential for the Rocky Mountains, where conventional locomotives struggled to maintain consistent traction and speed. The Big Boy was engineered specifically to dominate these high-altitude corridors, where the air is thin and the inclines are punishing. Everything only gets more complicated when the engine faces a long-haul ascent under full load. Active service for these machines concluded in 1959, leading to a long period of dormancy for the legendary fleet. It seems simple to leave a machine in a museum, but in reality, the components require constant preservation to prevent total decay. In 2013, Union Pacific initiated the most ambitious steam restoration project of the modern industrial era. The locomotive was extracted from a facility in Pomona, California, to undergo 6 years of meticulous mechanical overhaul. The camera glides along the polished steel surfaces that were stripped and rebuilt by hand to meet modern safety standards. 2019 marked the official return of the 414 to the National Rail Network. Since its reactivation, the locomotive has toured the United States, attracting crowds that number in the hundreds of thousands. During a recent transit through the state of Texas, more than 1 million people tracked the progress of the machine via roadsides and digital monitoring systems. One can notice the immense scale of the engine as it passes modern infrastructure, dwarfing contemporary diesel units. The metal lays in an even layer of black paint and polished brass, reflecting a renewed era of operation. Few modern transport systems can generate this level of public engagement or technical fascination. The locomotive serves as a physical record of a period when American railroads defined the landscape through high-capacity engineering and innovation. This machine represents the peak of steam-driven power, functioning as a bridge between historical heavy industry and modern preservation techniques. The restoration ensures that the mechanical logic of the 20th century remains functional for future observation. The material journey of the Big Boy continues as it moves toward its next destination on the transcontinental line. 100 locomotive legends represent the pinnacle of American engineering across a timeline defined by steel and steam. Why do these massive structures continue to command such immense respect decades after their construction? The answer lies in their specific mechanical purpose. These machines were not merely designed for the transport of freight or passengers, but were engineered to dominate the rails through a combination of raw physical strength and technical elegance. One can notice how the refined lines of the Daylight 4449 contrast with the overwhelming industrial presence of the Big Boy 40014. Each unit on this list fulfills a distinct mission and carries a specific technical legacy. They function as living symbols of a generation that achieved the impossible through mechanical precision. It only looks obvious that they are just machines, but in reality, they are historical monuments that challenged mountain grades and crossed vast deserts. The equipment gradually transitioned from simple tools of transport into instruments of national progress and ambition. This journey through the most impressive locomotives in American history reveals the sheer scale of machines built on steel and ice. But this is just the beginning. The process of documenting these engineering marvels continues as new records of incredible machines are compiled every week. Each locomotive represents an era where steel rails connected distant cities and fueled the growth of a continent. Everything only gets more complicated when considering the individual stories of the crews who operated these giants from within the cramped cabs. It is visible how these legends carried the weight of history across thousands of miles of track. The material is ready to move to the next processing phase without haste. Thus ends one of the key stages of exploring the most imposing locomotives ever built on American soil.